I'm using a technique called mutualinforegression to pick the best features for prediction. It's like a detective searching for clues. The stronger the relationship, the more important the feature. I have a collection of data with multiple pieces of information. These are the different characteristics I'm studying, 5 to be exact, labeled as X1 through X5. This is what I'm trying to predict. It's a number, not a category. I'm using a specific tool from Sklearn, a popular Python library, to do the feature selection. Sklearn provides many helpful functions for machine learning. These numbers show how strongly each feature is related to the thing I want to predict. Higher is better. Feature X1 has a strong relationship with the target variable, y. Feature X2 has a weak relationship with the target variable, y. Feature X3 shows no relationship to the target variable, y. Feature X4 has a moderate relationship with the target variable, y. Feature X5 has a weak to moderate relationship with the target variable, y. I need to figure out which features are most helpful in making accurate predictions. We're using a technique called mutual information regression from the Sklearn library to figure out which features are most important for predicting the target variable in a regression problem. It's a way to perform feature selection. Think of it like this. We want to find the best ingredients to make the best cake. I have 5 features, X1 to X5, which are like the different ingredients for my cake. The target variable, y, represents how good the cake is. My goal is to predict how good the cake will be based on the ingredients I use. Mutual information is a way to measure how much information one variable gives us about another. A higher score means the feature is more helpful in predicting the target variable. We have scores for each of my ingredients, features, that represent how much each one helps predict the target variable, y. For example, X1 has a score of 0.8, meaning it's strongly related to the quality of the cake, y. These are the actual mutual information scores. Look, X1 has the highest score, 0.8, meaning it's the most important ingredient. X3 has a score of 0.0, meaning it's completely unrelated to the cake's quality. The rest fall somewhere in between. Based on the mutual information scores, let's determine which statements are correct. This is the quiz question itself. We need to interpret the scores and decide which statements are true about feature importance. I see the mutual information scores for each feature. These scores tell us how strongly each feature is related to the target variable, y. A higher score means a stronger relationship. For example, X1 has a score of 0.8, which is the highest, indicating the strongest relationship with y. X2 has 0.1, X3 has 0.0, X4 has 0.6, and X5 has 0.3. Pretty neat, huh? This row shows the actual numerical scores that we just discussed above. We use these to decide which features are most useful for predicting the target variable. Remember, a higher score means a stronger relationship. This is what we are trying to figure out, which features are the most valuable for making predictions. Based on the scores, I can determine which feature helps us predict y most accurately, based on how related it is to y. This is what the whole exercise is all about. This is the actual quiz question. I need to determine which statements are correct based on the mutual information scores. It's all about carefully examining those scores and understanding what they mean. These are the 5 features in our dataset. I'll be using them to try to predict the target variable, y. This is what I'm trying to predict using the features. It's a continuous variable, meaning it can take on any value within a range, not just specific categories. This is a technique from the Sklearn library in Python. It measures how much information one variable, a feature, gives you about another variable, the target. In simpler words, it tells us how well a feature can help us predict the target. This is the result of applying mutual information regression. The scores tell me the strength of the relationship between each feature and the target variable. I'm using mutual information, a statistical method, to figure out which features are most useful for predicting the target variable in a regression problem. Think of it like this. I'm trying to find the most important ingredients in a recipe to get the best tasting cake. I have a collection of data. This data includes 5 features, x1 to x5, which are like different ingredients in a cake recipe, and a target variable, y, which represents the final quality of the cake, e.g., how delicious it is. These are the 5 different characteristics or variables in my dataset, like the amount of flour, sugar, eggs, butter, and vanilla extract. This is what I'm trying to predict, the final outcome. In my cake analogy, this would be how delicious the final cake tastes. I'm using a specific function from the scikit-learn library, a Python library for machine learning, called mutualinforegression. This helps me understand the relationship between each ingredient, feature, and the overall taste, target. It measures how much knowing the value of a feature helps in predicting the target variable. The output of my mutualinforegression function. Each score represents how strongly a feature is related to the target variable. A higher score means a stronger relationship. These are the actual scores I got. For example, x1 has a score of 0.8, suggesting it's very strongly related to the target, while x3 has a score of 0.0, indicating no relationship. Based on the mutual information scores, I can rank the features in order of importance for predicting the target variable. Higher scores mean more important features. This is the core question of my quiz. Based on the scores, which statements are correct? I need to check if this statement is true considering the scores I obtained. I need to check if this statement is true considering the scores I obtained. I need to check if this statement is true considering the scores I obtained. I need to check if this statement is true considering the scores I obtained. This shows that feature x1 has a mutual information score of 0.8. That's a pretty high score. It suggests a strong relationship between x1 and the target variable, y. I would consider x1 a very important feature for prediction. Here, feature x2 has a mutual information score of only 0.1. This indicates a weak relationship with the target variable compared to x1. A score of 0.0 for x3 means there's no relationship at all between this feature and the target. We can safely say x3 is not useful for predicting y. x4 has a decent score of 0.6. It shows a moderate relationship with the target, but not as strong as x1. x5's score of 0.3 indicates a weak to moderate relationship with the target variable, y. It's less important than x1 and x4. I see the mutual information scores for each feature. These scores tell us how strongly each feature is related to the target variable, y. A higher score means a stronger relationship. For example, x1 has a score of 0.8, indicating a very strong relationship with y, while x3 has a score of 0.0, meaning there's no relationship at all. These are the 5 features we're evaluating. I'm using scikit-learn's mutual_info_regression to understand how each feature helps predict the target variable. This is the method I used to calculate the scores. Mutual information is a statistical measure to quantify the amount of information obtained about one random variable by observing another. In simpler terms, it measures how much knowing the value of one variable helps you predict the value of another. Sklearn refers to the scikit-learn library in Python, which is a popular machine learning library I use. Based on the scores, I can rank the features by their importance. A higher score means the feature is more important for predicting the target variable. The dataset contains the features and target variable used in feature selection. I have 5 features, namely x1 through x5. This is what I'm trying to predict using the features. It's a continuous variable, meaning it can take on any value within a range. These are the 5 features, or input variables, we're using to predict the target variable. Think of them as different pieces of information we have about something. For example, if we're trying to predict house prices, these might be square footage, number of bedrooms, location, year built, and lot size. This is what we're trying to predict. Sticking with the house price example, this would be the actual price of a house. This is a statistical method from the scikit-learn library, a popular Python library for machine learning, that I'm using to figure out which features are most helpful in predicting the target variable. It measures how much information each feature gives us about the target variable. These are the results from the mutual information regression. Each number shows how strongly each feature is related to the target variable. A higher number means a stronger relationship. X1 has a score of 0.8, meaning it's very strongly related to the target. X3 has a score of 0.0, meaning it's not related at all. These are the specific mutual information scores for each feature. The scores range from 0 to 1, where 1 indicates perfect correlation with the target variable and 0 means no correlation. X1 shows the strongest relationship with Y. This section presents the multiple choice questions based on the interpretation of the mutual information scores. This statement is true because X1 has the highest mutual information score, 0.8, indicating the strongest relationship with the target variable. This is also true. A score of 0 means X3 provides no information about the target variable. This is false because X2, 0.1, and X5, 0.3, have different scores. X5 is more important than X2. This is false. There is no one-size-fits-all threshold. Deciding which features to keep depends on more than just the score. It involves considering all the data and even some intuition.